The truth is, attackers are no longer breaking in, they are simply logging in. Hi, I'm Dwayne, developer advocate at GitGuardian. I'm here to introduce you to the GitGuardian platform, which is helping companies fight and solve the problem of secret sprawl, which is a major component in so many breaches today. The GitGuardian platform is focused on finding hard-coded, plain text credentials that appear in the codebase, but they also appear in places like the CI/CD pipeline, container registries, messaging systems, ticketing systems, and anywhere else where you can find text. We do this by publicly monitoring GitHub, and we also do this by connecting to internal systems such as your version control systems and your internal ticketing systems. Once we have a handle on all of your hard-coded secrets, we're also helping companies find better paths for managing all of the entities that use those secrets, those non-human identities. By the end of today, we'll take a look at our platform in action. I'd like to say that we very much are fortunate to partner with Terology to help serve the Japanese market, and we're very proud to work with you. Today's presentation has 4 parts. We're going to take a very brief look at some major incidents that have happened recently in Japan that could have been prevented if secret sprawl wasn't a problem. And then we'll take a look at the scale of the global problem of secret sprawl, and then take a look at the root causes of how we got here. Finally, we'll talk about how the GitGuardian platform can help you solve this problem for your organization. Let's start with a look at a few real-world breaches. Very recently, as the time of making this video, the Asahi Group was attacked by a ransomware gang that was able to penetrate the organization, ultimately locking 1.19 million customer records, and very probably leaking them onto the internet. This is an ongoing investigation, again, at the time of this recording. While the attackers gained access initially through a user account, they were able to quickly escalate their privileges and move laterally through the systems, most likely because they were able to find credentials that were hard-coded into places where they shouldn't be. Sompo Japan, the insurance company, suffered a major data breach that exposed 7.27 million customer records. The attackers got their initial foothold through a non-core internal web system that didn't have proper authentication. Once inside, they were able to explore the network and quickly found other credentials, leading to wider foothold and the ability to finally take over the entire network. NTT Communications disclosed that they had a data breach that affected 18,000 external organizations. As a major telecom provider, if they are breached, all of their customers are at risk. While the exact details of this breach have never been publicly disclosed, according to research from Beyond Identity, the most likely vulnerability that was exploited was compromised credentials. We know it's a very common problem, especially in companies as large and as old as NTT Communications. There are many other examples we could go through at fine detail, but instead of going through each one by one, the Casio, the Escool, the Kintetsu, and even Panasonic, all of these are easily discoverable with a quick Google search. Let's step back and look at how these attacks overall take place and where credentials fit into that. The way attackers behave is so commonly known that the MITRE Group in the United States made an attack framework. According to their research, almost every cybersecurity attack ever pulled off follows these general steps: initial access, execution, persistence, privilege escalation. I won't read you the whole list. Our focus today is on credential access, which leads to lateral movement. Once a key is found, attackers try them in every door they can and move into that new area. And what's the first thing they do when they move into a new service or a new platform? They immediately start trying to discover more hard-coded credentials that will allow them more access. The wider their footprint, the more damage they can do, and the more data they can collect. In 2025, Verizon, the data breach investigation report they put out every year from their security team, listed credential-led attacks as the #1 initial access vector. Meaning this is no longer just a problem after the attackers get that initial foothold. Now, this is the main way attackers are getting in, through compromised credentials. So how bad is this problem at scale? Well, that's what we research here at GitGuardian. One thing we know for certain is that secrets get exposed throughout many, many, many different kinds of systems. While we can blame developers primarily for secrets in code, secrets also end up in log files, CI/CD pipelines, but then places away from the code pipeline and the software development lifecycle, in places like our internal wikis, in messaging and ticketing systems, in cloud and data buckets and other subsystems, and knowledge apps. These secrets take many forms, but at the end of the day, they do the same thing. They grant access with a level of authorization. This can take the form of an API key. This can take the form of a certificate. This can take the form of a token. It can take many, many forms. The one thing we know that's absolutely true about them, though, is they leak at scale. Every year, GitGuardian puts out a free public report. We would invite you to download this and research it on your own later after this video. But in the year 2024, we saw 23.77 million hard-coded credentials get added to public repositories on GitHub. That's not a cumulative number. That is just the number of credentials added in the year 2024 alone. That marked a 25% increase year over year. This represents 15% of all commit authors across 4.6% of all public GitHub repos pushed at least one secret into the public. The same report also reveals that we know this problem is at least 8 times worse internally. When our customers and users first connect their private repositories to GitGuardian, we immediately find 35% of repositories contain at least one secret. The kind of secrets they contain also differ from those in public. ODBC connection strings, Amazon or AWS IAM credentials, and things that don't typically show up in public repositories but are very, very, very dangerous. We think there's a false sense of illusion or a false sense of security that many companies have because they feel they're in a private network. And especially now that we moved mostly into the cloud, there's no really such thing as that private boundary anymore. The perimeter really has become the identity. And I've mentioned it a couple times already in this call, but we're also seeing secrets pop up in places outside of the code base. Now, why I'm showing you this slide and reiterating this is when customers report back to us on the criticality of these findings, it's always more severe. These are more critical findings and higher sensitive keys that get pushed into these other systems. There's only an 8% overlap as well, almost 8% overlap as well, between secrets found in these tools and in the code base, meaning that secrets found in the code typically are properly stored, but then make it out of that proper storage, the vault system, the secret management system, into these other tools. One of the worst findings that we've found is that if a secret is valid when found, there is a very high likelihood it will stay valid, meaning it will still work. Of all those keys we tested that we found in 2022, when we retested them at the beginning of 2025, almost 70% came back as valid still. We don't really just have a leak problem, we have a rotation and secret management problem at scale. And we really honestly wish we could say that artificial intelligence was helping this situation, that all of the coding assistants were making the problem better. But unfortunately, we have the evidence from that same report that it's making the problem worse. Evidence files and systems we see leveraging Copilot had a slightly higher percentage of leaked secrets. It was 6% of all public repositories contained a secret, as opposed to 4.6% of generally all repositories. Why is this problem happening? What are the root causes of secret sprawl? I personally, and GitGuardian believes, there are 4 major root causes. First is we have never built as much stuff as we have right now. Microservices architecture just require many, many more connections. Cloud migrations also give us more chances to expose the code base, moving outside of our secured internal perimeters into places that are internet accessible to anyone that has the URL. AI generated code is creating more hard-coded secrets in some unexpected ways, and we'll get to that in a bit. I have explanations for all of these. And finally, developer pressure is very real, and human error is ultimately the cause of most of these credential problems. So when we talk about microservices and microservices architectures requiring more API connections, what we're really talking about are our applications have become more complex today. We refer to them as non-human identities. That is any workload or machine that is running that needs to connect to another system, another running workload in order to accomplish a task. These come in many forms, from Kubernetes clusters to microservices you build, stateless applications or serverless applications, CI/CD pipelines, third-party apps. This is how we build modern applications. It's rare that someone will build a monolithic application all in one code base that does everything within that one code. Normally, code bases connect various services. This has been on the rise for years. Over the last 10 years, we've seen an explosive growth of the number of NHIs. In fact, our research shows us that we're looking at about 100-to-1 ratio, meaning every single password a human has, there are at least 100 other credentials, API keys, tokens that go to something that is not human, be that an Internet of Thing device, be that a workload, be that anything else. This directly maps to the number of breaches we see that's been increasing rapidly over the last few years. And why we focus on the non-human identity side in these microservices architectures is, unlike humans, machines can't use multi-factor authentication. They don't have fingerprints, and they can't use their phones to unlock or authenticator apps to get a code. For the most part, these systems are built that if you present a credential, you're simply allowed into the system to do whatever you want to do. Because developers are always worried about downtime, they tend to overprivilege these entities, these non-human identities. So the keys they have are typically very powerful. If you find a key that allows access to all of your GitHub repositories, just for example, and allows you to write to those repositories, you can insert whatever malicious code you want. I bring up GitHub specifically because 99% of the keys we find for GitHub that grant any kind of access grant write access. Typically, these keys live indefinitely with very long lifespans. Now, we are seeing a growing trend toward moving toward shorter lifespans, especially using JSON web tokens and other technologies that expire the credential. But traditionally, legacy applications we've built simply have keys that live forever. We have a saying that we like. We don't actually like it, but the truth is attackers are no longer breaking in. They are simply logging in. If you have a key and you can simply turn the knob and go through the door rather than having to knock the door down, it's much harder to detect that intrusion. In fact, most companies can't tell an intruder is there until the attacker has started to do something bad. such as exfiltrate data. Just because someone accessed the system doesn't know they shouldn't be there until another system alerts a human or another monitoring system that an unexpected action is taking place. And by that time, you're typically too late. And we wish this was just isolated to internal repositories and internal systems. But again, because we live in a very interconnected world of microservices in our architectures, and we're very reliant on third parties, if they're breached, there is the possibility that you will be breached. Now, there are safer ways to approach this, and we are seeing those in the market today, but mostly we have dealt with third-party services the same way we did with internal services and simply gave it a long-lived, over-permissioned key that had no expiration date. What keys did you give them? What keys did they give you? How are you tracking that? That's what leads to this massive bit of secret sprawl that feels very hard to manage. Cloud migrations have also played a part here. Earlier in the world of technology, we built little fortresses, perimeters that were very hard to penetrate, very hard to get through, defenses. But now we're pushing code to more and more cloud providers. I'm not going to list them all here, but AWS, Azure, Google Cloud are three of the most popular, at least in the United States where I live, but there are many throughout the world. They're fall into some general categories though. So pushing in the public cloud, meaning anyone can access that. There are some ingress and egress rules, but it's a little bit harder. You can build private clouds that are feel a little bit safer, but again, they're just clouds, servers you don't own running somewhere. And again, they're addressable by the internet. And you can have various states of that, servers you own that are operating as if they are cloud. But most organizations end up in this area here of multi-cloud. They don't have a single provider. It's very hard to defend one provider. It's very hard to defend one system. But if you're trying to defend against attack while you're spreading your code base across multiple systems, it's just very hard to fight a battle on so many fronts at once. Now, AI generated code, the next one on our list, we do feel that it is contributing to additional credential leaks, but in some unexpected ways. We do see an uptick in the number of secrets leaked by people using Copilot. We feel that's partially due to Copilot's adoption by people that don't have a lot of familiarity with code, your vibe coders, as we call them. That is part of it for sure. But as all developers learn as they move through their careers, there are certain things they have to do in order to stay safe. And we think that those basics that are being taught aren't really showing up in the big numbers yet. We'll see what the future holds and the future numbers from our investigation into how fast we're building and what people are building. But AI generated code simply means we can first move faster, but the AI systems themselves are leaking secrets in new ways. If you ask a chatbot, give me a password, there's a possibility it will give you the password. Where did it get the password from? The internal systems that it connected to. This is a diagram, oversimplified diagram of an LLM that leverages RAG, Retrieval Augmented Generation, meaning the LLM has access to a knowledge base that connects to other knowledge bases, that connects to external systems, connects to your Notion, your Salesforce, your Confluence, your Jira, your Slack, and can pull information from there, making the LLMs very powerful. If there's a secret in any of those systems, that secret is now within the AI. And so it might simply pass the password back. It might pass an example snippet of code. It might pass a configuration file that contains a hard-coded credential. More and more, we're seeing these systems attacked directly by adversaries. Especially in 2025, we saw some of the largest attacks that directly go after the AI itself. But there's another danger here. Because the way we train large language models, We know the input going in, and then we log the output coming out, and we see if it did what we expected it to do. Those log files, we find a lot of the times, do contain a credential as the LLM is trying to figure out a build process or build script. And while we don't want it to show the credentials, it more likely than not will sometimes. This is a whole new attack surface. Attackers love to look in S3 buckets and other public object storage to try to find these logs to see, well, what was leaked and what can I get into? So AI is definitely increasing the amount of secret sprawl, but again, in some surprising ways to us. Developers have never delivered faster. We've never written more code. This diagram comes from the Octoverse State of GitHub report. Every year, GitHub puts out a report about how they have evolved in the last year. And this was a number that really stuck out to me. We have dramatically sped up how fast we close issues, how fast we push code, and how much code we push. I would invite you to investigate that report on your own because there's some staggering numbers from there. But I think this really tells the tale. We're doing millions of more pushes per month. We're doing millions of more pull requests a month. Simply, there's millions more lines of code per month that might contain a secret. Now, developers should be using alternatives to hard coding secrets. So while they're trying to deliver quickly, they are told to stop what you're doing, go and put any new keys, any credentials you've made into a proper vault system. And we agree that is a good overall strategy. The problem is, from the developer perspective, that is slow and takes them out of their workflow. And worse yet, most organizations don't just have one vault. Most organizations report having a minimum of 6 different vendors with hundreds of different instances of those vaults. So from a developer perspective, not only do they have to figure out where to put the key, they need to also figure out where to get it from. What state is it in? Does this key even work? How would I rotate it? Who do I request access to get it from this vault that I currently don't have access to? It's just a lot of pressure. Meanwhile, the clock is ticking. The day is ending. They want to go home to their families. So what do? Well, unfortunately, a lot of times we see them take shortcuts. And the biggest shortcut they take is simply hard coding the credential, leading us back to this initial problem of secret sprawl. We see them committing those secrets, and that's how they end up in public and in internal repositories. And they share those plain text secrets across other sources, across tickets. The number one reason we've heard from our customers that Jira tickets contain a hard-coded credential is because it was one engineer trying to be nice to another engineer and just help them get their job done. So they'll simply put the credential in the ticket. The next person working on it doesn't have to do all of the work to properly authenticate. They can simply get in and keep working. We see developers also not mitigating secret leakage because they're trying to hide their mistakes. Unfortunately, the way that modern version control works, if you've committed something, it's there forever. So people will tend to just pull the secret back out on the next commit and hope no one notices. Unfortunately, attackers know this and are constantly looking at old branches, at old commits, at orphan commits, trying to find those secrets. Only true remediation for a leaked secret is to invalidate the secret and replace it. There's no exceptions to that. In the last few minutes we have with you, and thank you for your attention and time today, I would like to talk to you about the GitGuardian platform and how we're approaching the problem of secret sprawl. We see a very clear path that all of our successful customers have taken. First, they take this problem very seriously, as you are today when you're engaging in this video. Implementing the right tools for discovering and monitoring secrets across the repositories and other places where text occurs. That's exactly where we come in. and then investing in the right tools to move those secrets into secret managers and then map out what's inside of those secret managers. Once you've done that and you know the state of these secrets and you know you can properly rotate them and you know your developers are no longer adding new ones, then you can move to secretless approaches, identity-based workload authentication strategies like OIDC and other OAuth-based mechanisms. We won't go into that today at all. The future is very bright there, and there are many paths you can take. But no matter what path you take, it follows this general pattern. Find the secrets, put them in the right place, rotate them, and make sure the developers never need to hard code a secret ever again. Now let's actually talk about what our platform does in that plan. We help companies detect their secrets, both internally and publicly leaked. If it's in plain text, it shouldn't be, and we're going to find it. We help teams prioritize which of those findings is the most critical with a very high degree of certainty. So when you're triaging the problem, you know what to work on next for the maximum effect. We're helping teams remediate those problems by streamlining the entire remediation process. Ultimately, we're helping teams prevent new secret leaks by providing their developers real tools to help them not commit secrets anymore. At the same time, we also are doing deceptive technology to put decoy credentials throughout code bases. So if you are breached, you know that you have an intruder before they've actually accessed anything that's dangerous or real. Ultimately, though, we want to inventory all of your secrets, the ones that have been leaked publicly or internally in plain text, and also across your vault systems. We have connectors into all the major secret management providers out there and can give you a full-blown inventory of all the secrets you have, and therefore all of the entities that leverage those secrets, and can start telling you how they're being used. And we can keep an eye on your secrets, so as you're onboarding new secrets, you ensure that they end up in the right place and are used correctly. If we step back and look just at the detection side of the GitGuardian platform, which is the way most customers engage with us, I'll give you a very quick demo of exactly how we work. And we'll just focus on this area of monitoring, detection, alerting, and remediation. When we talk about monitoring, we're talking about monitoring the right places. There are, again, two things that we can monitor. And forgive the screen drag here, but I'm going to show the GitGuardian platform. When we say monitoring, we're talking about monitoring both publicly out on GitHub and your internal code repositories, your container registries, your package registries, your documentation systems, your file storage, your messaging systems, your ticketing systems, your CI/CD pipelines. And we've actually added the ability to monitor any source that contains text. We call it bring your own source. We also monitor public GitHub. So when I say that, what I mean is we are looking out in public GitHub for your secrets, but not just from your organization and not just from your developers who use your email address. We can identity stitch together if a subcontractor and their contractors underneath them have leaked your data, because we will get to know you as a customer. We won't get into the details in that, but we would love to work with you to give you a full detailed view of our public monitoring product. So if I look at our internal secrets here, I have a full list of all of the recent incidents that have happened due to an internal leak across an internal system. Here we see Slack, here we see GitLab, here we see JFrog, which is a container registry. But what are we detecting? That's that next piece off of the chart. Well, that's our table of detectors is the easiest way to demonstrate this. Currently, as of making this video, we have over 560 total detectors. Those fall into two very broad categories. First are specific detectors that map to a specific service or product. For a subset of those, we can actually do something called a validity call, we can check and see if the key actually works and see if it would allow an attacker access. We can't do that on all systems, but for many we can. For most we can. There's another type of secret though, another type of secret detector we build for secrets that we're not 100% sure what they go to, but they are being used to actively grant access to another system, such as a bearer token or a base 64 string. We have machine learning technology that we have built over the last few years that help us, with a very high degree of precision, know that these are in fact real secrets, they are being used, and you get the lowest false positive rate of any secrets scanning provider on Earth. Of course, we'll send you alerts where you need them. I won't go through the full list, but I will tell you our alerting system can be set up with custom webhooks. So it can work with Slack, Teams, of course, email, anything else, a seam, your SOAR, any other tools that can take an incoming alert. We would happily integrate with those. But do talk about a remediation. For that, I am going to go back to our platform. So forgive again the slight change in screens here. But if I'm looking at a public incident, something that is valid and has been shared. Now I'm in privacy mode here, so I'm not worried about showing you one of these, but let's look at this internally leaked secret that also has been leaked publicly. So if I look at a quick overview, GitGuardian has the ability, if you fully integrate us, to show you not just the secret and its current state and a current risk score, but also where that secret is being stored, what entities are consuming it. That's part of our NHI governance platform. What that secret goes to and what state it's in. This one has been leaked publicly, which is the incident we're looking at now, but I can also quickly see it's also been leaked internally. As we like to say around here, it's very rare you'll have a publicly leaked secret if it wasn't also leaked internally. Now, if I wasn't in privacy mode, I'd be able to see the secret itself. It's valid. And in this particular case, I can see exactly what scope that secret held. Now, of course, I have security operations workflow things here. But very importantly, if I am going to try to remediate the secret, I need to know some information. The person who would know this information is the people that leaked the secret, in this case, Pierre. Now, I could go and invite him here and to look at the same screen, but I'm also able to share this link to ask for feedback. I'll start a new incognito window here very quickly. Give me just a second and paste it here. And you can see I can ask that same information to that developer very easily. And when I'm done, when I'm done using that, I can simply turn it off and it's no longer available, making it very safe to share that. Of course, we provide analytics along the way, and we also provide developer tools, which I will not demonstrate today, but we have a developer toolkit called GG Shield. It's a command line interface where developers can set Git hooks to automatically catch secrets before they're committed and before they're pushed from their local development machines. We also offer a VS Code extension, which allows developers to catch secrets that are hard-coded right as the file is saved and before they ever enter the Git workflow. GitGuardian's been around since 2017. We have a long list of world-class customers as we focus on the enterprise and large-scale companies that have very serious needs around security, compliance, auditability, and ultimately security for their customers. We help teams find hard-coded secrets wherever they may appear, and if they're in the wrong place, meaning plain text, especially in public, help them remediate that situation by moving the secrets somewhere safe, such as a vault, and making sure that the proper rotations can happen and that future leaks are caught immediately. We would love to work with you as your teams continue to build out more and more systems with non-human identities connected together using secrets and other access mechanisms, other authorization mechanisms to help you do that safely at scale. And again, we're very proud to partner with Terology, who's helped make this video possible, and we would love to work with you directly. Thank you very much.